Hello everyone, how are you? We are moving to a new chapter in Calculus 2 called Sequences and Series. If really wants to know a clear description of a sequence, sequences always deal with patterns. If you go look inside our nature, we do have many patterns. If you take your thumb and find the circumference of a thumb, and if I call this one maybe 2, 4, 6 centimeter, if I double this one, which is 12, you get the circumference of the wrist. But if you take that 12 and double it, you get the circumference of your neck. But if you take this one and double it, I bet you that become the circumference of your waist, which is pretty much many people, whenever they want to buy a pant, they fold it in half and they wrap it around their neck. And then if double the wrapped around their neck and it fit their neck, then they open it up. That become exactly their pant size. If go outside and look at the trees, a tree has a trunk. That trunk might ended up with another branch. That branch is going to get bigger, but that branch become 2. Then here you have 1, here you have 2, here you have 3. As this get larger, this become 2, and that's become 2, and that's maybe stay the same. Therefore you see this is 5. This eventually gonna go up and become 2. Maybe this also become 2, and this become 2, but maybe these two go up and they don't branch off. And if you look at that one, 1, 2, 3, 4, 5, 6, 7, that become an 8. Then what is 1 plus 2 is a 3. What is 2 plus 3 is a 5. 5 plus 3 is a 8. I bet you the next one is going to be 13. Why the tree grows like that? Because everybody fighting to get the most sun. That's the created that the God, that's a pattern that the God created, and how they can survive. And I don't want you get me wrong, there is a root also here too. And what is 1 plus 1 is a 2. Let me talk to some of the male students. Maybe you go to the bathroom, to the men's room, and you see 2 urinals, and there is 2 of you. You're gonna have no choice to put 2 of them next to each other. But what happens if that become 3? I bet you're not gonna stand next to each other. One stay here and one stay there. That's 1 and 1. But if I add another urinal and instead of 2 people, I have 3. One has to stand next to another one, either here or there. There is no empty space between them. Therefore, you got a 3 right there. And if I have 1, 2, 3, 4, 5, if 2 people go in here, one gonna stay here, the other one is here, or here, or here. He's not gonna sit here. If it's 3, one gonna stay here, one gonna stay here, one gonna stay here. If it's 4, one gonna stay here, one gonna stay here, one gonna stay here, one gonna stay here. One is gonna be blank. If it's 5, let's see what happened. And that's because, I'm sorry, let's make it a 6. You have 1, no 1, 1, and this one is 1 and 1 is 2 and 3 and a 4 and a 5. But let me think about 1, 2, 3, 4, 5, 6, 7, and 8. Let me put 8 urinal with 5 person. I bet you one stay here, one stay here, one stay here. Therefore, so far I have 1, 2, 3, 4, and a 5. See, if you have 8 urinal, that's how they gonna stay. What happen if you have 13 of them and 8 person? One gonna stay here, the other one gonna stay here, the other one gonna stay here, no one here, the other one gonna stay here, no one here, the other one gonna stay here, no one here, the other one gonna stay here, no one here. Let me see. 1, 2, 3, 4, 5, 6, 7. That's exactly how they stay, but one of them have no choice to stand next to each other. Then the way even stand next to each other is going to be 1, 1, then it's going to be 2 next to each other, then it's going to be 3 next to each other. Therefore, it depends how many urinal have. You have 5 and 8 and so on. Therefore, there is a pattern that we see all over in nature. Therefore, somebody said, what is a sequence? In mathematics, we use the sequence the same way we use in ordinary English language. And we're saying sequence is a collection of objects. Or maybe it's a collection of events, like birthday, like wedding. But if you're going to have a collection of the wedding, you must have certain kind of a pattern into it. Therefore, if you have a collection of objects, and if you or a collection of events, and it does have a pattern into it, that's called sequence. Therefore, if I have 1, that become a 3, that become a 5, that become a 7. I bet you after 3 or 4 terms, you can see my pattern, that I'm taking the previous one and add it 2 to it. Therefore, this is a collection of numbers with some kind of a pattern. How can we define sequences in mathematics? We can do it 2 different ways. We can do it implicitly. Why do I mean doing it implicitly? Well, we know the rules, and we're using recurrence relationship. By knowing the first term and knowing the rules, we can find the next term. We have this one, we have a third one, we have a third one, we have a fourth one. Therefore, if you're going to use recurrence formula or relation, this is called an implicit formula. And in this case, the first term is always going to be given. Therefore, a sequence has a name, like we did on the function. We call it sequence represented by A, sequences represented by B, sequences represented by C. But when I talk about event, you cannot have 1.5 wedding, 1.5 birthday. You cannot have object and say 1.5. It has to be whole object. Therefore, the domain for sequence is always integer number from 0 through infinity, and but it has to be an integer number. And you can approach infinity, but you can never reach to infinity because you don't know what it is. You're not going to include it. And we are going to use those integer number by a letter L. N means 0, means no wedding. 1, 1 wedding. 2, 2 wedding. 3, maybe 3 birthday. 4 birthday, 5 birthday. Therefore, we can use A1 and use this one to represent my sequence. Then very much I am looking for a formula. If you give me a formula, this is called explicit form. Then we have implicit form, which specify the initial term of the sequence. Like sometimes A1 is 1, or maybe I started with a 3, maybe I started with a 7, I don't know. And gives a general rules. What am I gonna do with the previous term? But in order to find the following term or succeeding term, you need the preceding term. But sometimes I want the 20th term without you giving me the 19 or 18. Maybe you only give me the A1, the first term. I need a formula. Therefore, I'm going to define it explicitly using A sub n or B sub n or C of n. Therefore, in this one, I have A sub n equal to 1. That's my initial term. Plus, the difference is 2. Okay, what happened if I put n minus 1? I made it up. And n becomes 0. N equal to 0 does not make sense. Therefore, in here you have to say my n must be greater than 0 and must be an integer. Why? Because if n become a 0, you have 1 minus 2, you have a negative 1. But I told you A1 is 1. Okay, but what happens if n is 1? Let me see. 1 minus 1 is a 0. 0 times 2. When n is 1, I get this one. But I don't have a sub 0. But what happens if I want my second? In here means n is 2. 2 minus 1? 1. 1 times 2? 2. 2 plus 1? I got 3. What is ace of 3? Is 1 plus 2 times n minus, here n is 3. 3 minus 1, 2. 2 times 2 is 4. 4 minus 1. Oh. What did I put right here? For A1, I put 0. For A2, I put 1. For A3, I put 2. For A4, I'm going to put a 3. Therefore, do you see this one right here? This is exactly 1 less than that, 1 less than that, 1 less than that, 1 less than that. Therefore, I do see by this formula of ace of n equal to 1 plus 2 times n minus 1, at least the way I look at it, it gives me all my terms. Means if I want the 100 first, if I want the 100 first term, that n should be 100. Because in here I have 0, 1, 2. But 0 gets you A1. 1 gave you the A2. Then n is always 1 below that. Therefore, that n, if I want the 100 first, ace of 100 first, I need 1 minus 2. N supposed to be 100. Then that's the 99. Times 2 is 198 plus 1 is an 99. This one called explicit form. Therefore, there are two different ways you can define your sequences. Implicitly, give me the first term and the rules, or explicitly you come up with some kind of a formula, and if you look at your graphing calculator and we press on and you press mode, you see that's a function. We study about it, because if you put plus on the function, every time y equal to, you see f of x, and in here when you press this one, you get only x, and you can graph it. But the minute change the mode to parametric function and you press y equal to, x and y are function of t. Therefore, in here you have to say t, I'm making these things up, and here t is square. Therefore, your x is a function of equal to t. Like if t is 1, x is 1, y is 1. If t is 2, x is 2, and y is 4. And when I press it, I get half a parabola. Why half? Because I don't have t equal to 0. But if I get from negative 2 to 2 with a scale of 1, maybe I get the other piece. But it's only traveling from negative 2 to 2. If I go to mode and change this one to a parametric polar function, you see that one. Cosine theta is going to be a function of theta. When I click this one, it gives me a theta. Therefore, what is a theta? Theta is supposed to be in terms of radian, and that's your x and y, and probably you get something like that. But let me go check my window, make sure my mode is on the radian mode. Yes, it is. Therefore, I don't need a lot of those 10, negative 2 to 2, and negative 2 to 2 with a scale of 1. Let me see, what does it do? Give me a circle. But the minute press mode in here, and I move to the last function we're going to study, it's called a sequence. Sequence is a function of n, not function of x. What is the difference between function of x and function of n? That x can be all real number as long as satisfy your domain. It could be 1, 1.000000001. It can be any number from a real number line. But on the sequence, that n can be 0. Remember object, remember the wedding, no wedding, one wedding. You don't like the first wedding, another wedding. You don't like the second wedding, another wedding. you cannot have 1.5 with it. That's going to be an integer number. But what is my range? It depends to your explicit formula. Therefore, if I go right here right now, look at what it said. It said f of n. But instead of f of n, they said u of n, v of n, w of n. Therefore, in here you can do, how many functions we can do? Only 3. Therefore, here is going to say, what is the minimum value you're going to use for your n? I'm going to press 0. And what you're going to do with your with your sequence? I'm going to say my use of n equals just this one. What is it? 1 plus, help me what this one is, 1 plus 2n minus a 2. That's 2n minus 1. Okay, 2n minus 1. And said, tell me what is the minimum value you want. Remember, the minimum value 1 is 1. I need the minimum value 1. I don't need negative 1. I don't want that n to become a 1 and you give me a negative 1. Therefore, you got to tell me what is the minimum value I'm going to want. And you automatically put them in the set. Then I'm go to window and I say, give me 10 terms. 10. And this is going to be plot started from 1 because we told them to start from 1 right here. Let me see if I change it to 2. What does it do? 2. When I go to window, see, plot is started from 1. But it make my n a 2 plus a step. Therefore, steps, you can put 0.1, 0.2, 0.3. But in here, because n is an integer number, you better put it 1 or 2 or 3. I'm going to leave it as 1. And I'm going to make this one started from 1, 2. But in here is my x. Well, if n is 10, I need at least a 19 here. Therefore, I go from negative 5 to 30 with a scale of 3. And my y value, I have to match it because when n is 10, I have a 19. I'm sorry. N comes in place of x value. Therefore, in here, my n is 1. Okay, I want to go to 10. Let me make it 12, 15 with a scale of 2. Let me make it, that's good. But my y value is your range. Therefore, I started from 0 and I get to 19, but I'm going to make it to 30. And I'm going to press graph. And if I press trace, when n is 0, your output is 1. And see, n and x are the same. Because really, this is x-axis, but we use it for n. When I put right here, oh, I'm sorry, I press trace, I get that one. What did I do? My change, negative 9 to 11, the scale of 0 to 16 with a scale of 2. I don't know what did I do. I press trace. Then I go right here, 1. Then I go right here. Is that a 3? Is it a 5? Is it a 7? It is a 9? If you do not have the explicit form, you cannot graph it. But right now I said n equal to 10. That's 8. That's 9. That's 10. That's 19. But see, it doesn't go anymore because you told them n equal to 10. Then sequence, what you need to know about it, it has a pattern. It can be defined by using n, and f of n, you can call it also a of n. In the calculator, they use this one, u of n. You have to tell them at what number n should start, and what do you want your a1 to be. I can put right here my n start from 5. Okay, let me see if I can do it. Okay, I'm gonna say my minimum n become a 5, but I want my minimum value to become a 3. Let me press trace. See, the minimum value is 3. See, that's a 3. But the next one, look at that. The minimum value was 3, was n, and then you go jump to a 6. And then it depends how you're going to tell them what you want and what they want your minimum value. Sometimes I make my minimum value exactly the same as my A1, or you can move it any way you want to. Okay. Therefore, what we need to know the first term, and we need to find out the pattern. Therefore, if your A1 is 2, what do you do with 2 to get 4? You double it. What do you do with the 4 to get 6? Do you double it? No. Oh, in here I have to say I add 2. Therefore, on the first time you could say add or double it. But the minute you get in here, you said no, you add. But somebody said, what happened if I write 2, 4, 8, and 16? And what do you do here? In here you can add or double. But let me double it. 2 times 2 is 4. Oh, double it. Double it. Double it. Then at least you need to know 4 or 5 terms in order to recognize the pattern. The pattern is very important. Okay. Right now we're going to talk about some sequences. And we're going to say maybe this is a set. That's a notation for the set. And under the parenthesis call is set right here. And then when you want to drop a set, you press second parenthesis, you see a set. And then you say 2, 4, 6, 8, and so on. And you have to close it with a set. And when you press enter, see, that's a set. And you said your a sub n. Some people say, can I write it u sub n? Yeah, if you write it as a u sub n, you're writing it as a function. Then you have to define your a1 and what is the minimum value for u sub n is. But I'm going to write it as a sub n, and I'm going to say this may become a set of 3 plus -1 to the power of n. Okay. And I'm going to say this is the explicit form, not implicit. I don't know the pattern, but I can see this pattern. Does that n become 0? I have 3. When n become 1, I have something else. Let me see what happened. Okay. In here, the very first term is 3 plus. And they have to tell you at what number your n must start. In here, I'm going to say your n is greater than or equal to 1. Okay, -1 to that's the first term. 3 plus -1. So remember, first weighting, second weighting. 3 plus -1 to the power of 3. 3 plus -1 to the power of 4. That's become 3 minus a 1, 2. That's 3 plus a 1 is 4. 3 minus a 1 is 2. 3 plus a 1 is 4. Do you see? That's my pattern. 2, 4, 2, 4, 2, 4, 2, 4. That is a beautiful pattern. 2 days work this week, 2 hours this week, 2 days this week, 4 days next week. 2 days the following week, 4 days the following week. 2 days the following week, 4 days. That could be a pattern in regular life. Or maybe I write b sub n, which is equal to a set, is n over 1 minus 2n. If they give you the pattern, oh, easily you can find the term. But if they don't give you if they do not give you the explicit form and they give you the pattern, and I said write the explicit form, is not an easy thing to do. Therefore, in here, can n become 0 here? Yes, n can be 0. You always have to remember n cannot make the bottom 0. Then let me start from n equal to 0. Okay, what is ace of 0? Is 0 over 1. What is ace of 1? 1, 1 minus a 2, which is a negative 1. What is ace of 2? 1 minus a 2 times 2 is 1 over negative 4, which is negative 1/3. I hope I'm right. Make sure I don't make any mistake. And what is the next one? Ace of 3 equal to 1. Oh, I made a mistake. N is 1 here and is 2 here. That's 2 and negative 1/2. Here n is 3 over 1 minus a 6, which is 3 over a negative 5 and is negative 3/5. Because I made a mistake here, let me check everything. N was 0 over 1. N was 1, 1 minus a 2. N was 2, that's the negative 4. Okay, 2 times 2 is and 1 minus a 4. 1 minus a 4, negative 3. Therefore, this is 2 and a 3. When n is 3, you have 1 minus a 6, and that is a 3. Therefore, that becomes negative 3/5. How about if n become a 4? You have 4 over 1 minus a 8, which is 4 over negative 7. Oh, then what is my terms? Negative 1, negative 2/3, negative 3/5, negative 4. Oh, that's also 1. What do you see on the bottom? Odd numbers. These are odd numbers. And somebody said, can I put my negative on the bottom? Yes, I move it upstairs. You can put negative 1, I put negative 2, negative 3, negative 5, negative 7. But in this case, you can leave it wherever you want. And what is the top? Your integer numbers. Therefore, this is negative 1 over 1, negative 2 over 3, negative 3 over 5, negative 4 over 7. Do you see? This is 1, 2, 3, 4, 1, 3, 5, 7. And that's exactly, you double the n, subtract 1, that's an odd number. And that's your integer number. Therefore, you do see a pattern right here. Therefore, sequence come in very different variety. Maybe I have C of n, and this one I have a pattern, maybe, let me think. Let me go back right here and say my n, square my n, and then 2 to the power of n minus 1. Remember, this is a polynomial, look like a polynomial, this is exponential function. But let me see if n can be 0. What is 2 to the power of 0? 1. What is 1 minus 1? 0. N cannot be a 0. Therefore, you gotta start from n greater than or equal to 1. Somebody say, can I make it a negative 1? I say, you remember, you're talking about future, wedding, birthday, 1, 2, 3, 4. It must be a positive number. Therefore, what is C1? It started from 1. 1 over 2 minus a 1, and is 1 over 1. What is C2? 2 squared over 2 squared minus a 1, and that's 4. 2 squared is 4 minus a 1 is a 3. What is 3 cubed? 3 squared over 2 to the power of 3 minus 1, 9. 8 minus a 1, and is 9 over 7. C4, I have 16. 2 to the power of 4 minus 1, I have 16 over 16 minus 1, and it's 16 over 15. C5, 25, 2 to the power of 5 minus a 1, and that becomes 25, 32 minus a 1, and that's 25 over a 31. Then what is this? Double it and add 1. What is this? Double it and add 1. That's what the nature of exponential function is. Exponential function 2 to the power of n is, if its power of 1 is 2, then is 4, then is 8, then is 16, then is 32. Take the previous one and double it. That's exponential function. Double it and add 1. The next term, whatever in the bottom, is 63. Let me see. C to the power of 6 is 36. 2 to the power of 6 minus 1, which is 36, over 64 minus a 1. And that's 36 over 63. Therefore, the bottom is always going to be exponential function 2 to the power of n minus 1, but the top is going to be a perfect square, and it's exactly your n square, n square, n square, n square. Therefore, we see a pattern. Then, since you know the pattern, in the next video, we're going to talk about the sequences, and maybe we apply some calculus to it. And the very first thing we're going to talk about is the limit of a sequence. What I'm saying, if you have 1 and 1/2 and 1/4 and 1 maybe 8th and 1/16, what the nth number is approaching. Number 1, do I have a limit when n approaches 5? Well, n is 1, 2, 3, 4. I do have a limit right here. But sometimes you're not able to find the limit, but it's possible to say what number you are approaching. Therefore, maybe your limit become exactly a number, or maybe your limit of ace of n as n approaches infinity approaches some number. Therefore, it becomes exact or approaches. And that's what we're going to talk about it in the next video. Thank you.